So now this is our lecture 17, and in this lecture we are going to touch the last part of the graph series, and after that we'll start equation of motion in 1D. So today's graph is going to be based on acceleration time graph. Okay, this session is going to be quite interesting because I will draw one acceleration time graph, and I will also show that if you know the acceleration time graph, then how will you judge which velocity time graph is the resultant of this acceleration time graph. I mean, if you have acceleration time graph, then you should know how to draw VT graph from this and how to draw ST graph from this acceleration time graph. Let's start. So see here, if your acceleration is written like 10 meter per second square, what does it mean? Meaning is 10 meter per second per second. What does it mean? 10 meter per second velocity is changing every second, right? But if this second you give here, so it becomes s square. It means what? 10 meter per second square. It means what? If you are going to convert acceleration graph into velocity graph, then see, okay, let's make it using one example. So suppose you have any AT graph which looks like this. What does it mean? Meaning is with time this property is not being changed. What does it mean? Meaning is your acceleration is not being changed. If acceleration is not being changed, then what I want to say here, acceleration is not being changed. It means what? Whatever is this value, suppose this value is 20 meter per second, then this 20 meter per second is not being changed at all taken time. At every single moment your acceleration was only 20 meter per second square. What does it mean? Meaning is your vehicle is moving, no doubt vehicle is moving, but it is moving with constant acceleration. Now see here, if velocity is zero, if your velocity is constant, then you differentiate the velocity, you get acceleration, and of course it will be zero because you are differentiating the constant answer. But if your acceleration is constant, get my logic, if your acceleration is constant, like in this graph, if your acceleration is constant, then I'll change the color. If your acceleration itself is constant, then this acceleration is nothing but dv by dt is equal to constant. Then this dt you take this side, you write dv is equal to constant times dt, and in very beginning chapters I have told you that these are the symbols of integration. Then we can simply integrate this, and if we are going to integrate this, then what kind of answer will be getting? You see here, if you will integrate this, then here you have to put integration sign, and here you have to put integration sign. Always remember, constant answer we don't differentiate, we don't integrate. Okay, so this part will become your velocity, and here this part will become your time. So c into time plus any constant we will write here. Anyway, we are coming to know that if your acceleration is constant, then your graph will look like this. But from this graph, if you want to draw your VT graph, then this type of situation will appear, and you can clearly see this situation is very similar to y is equal to mx plus c, where c is the constant. Okay, plus constant. Okay, so now you can clearly see, if I will draw a graph between y and x, in same way I have to draw a graph between velocity and time. Okay, so it is going to be a line, but of course your velocity is changing with time, so you'll be going to draw this kind of graph, velocity and time, because power is only one, that's why you are drawing the straight line. But by mistake, suppose somehow power is coming 2, in that case you should draw parabola. Okay, but right now in this case what I have taken from this guy, so your velocity is only this much, v is equal to t, so your straight line, only straight line. I hope it's very clear how it is going on. Now suppose if I will draw a different AT graph, suppose I am drawing AT graph like this, is this possible? So no, not at all. Any phenomena cannot happen in zero time. Okay, so you can see here time is not being changed, but values of a are being changed, correct, which is not possible at all. So that's why these kind of graphs are not possible physically. But what if your a itself is changing with time? So this kind of graph becomes example of jerk. It means what? At every second you have new acceleration. At every second you have new acceleration. Jhatka lagega, jhatka. You understand? Jhatka. Okay. So like jerk, sudden jerk. When acceleration is like, you will experience like all your muscle or your skin, everything is going backside in your body like that. It's like sometimes you can see in Hollywood or Bollywood movies when fighter planes are flying, and then you can see the faces, the skins of the pilot, they used to go back towards the seat, right? So this was the idea. Now see, remember, if you have AT graph, either you take this graph or you take this graph. In both the cases, I can find out velocity. How? I will tell you that from this time to this time, in between, calculate the velocity. Always remember, not the velocity, average velocity, because when some time interval is given, you remember or you have forgot the very basic. What is average velocity? You need a complete time duration, right? So now you can draw. If you have AT graph like this, and from this time to this time, if you want to find out your velocity, you need to find out the area, but that velocity will be average velocity. Okay, just a moment. Yes, so this velocity will be your average velocity. I hope everything is fine. So how will you know the area? How will you find out the area? Because, so first thing you remember the idea swag. Okay, so SVAG. In the swag, if you go like this, so area of acceleration time graph gives you velocity, area of velocity time graph gives you distance, right? So how will you calculate? So you should know this distance, and this distance will be given. We can solve this. Okay, so let's understand one very basic equation. I am giving you an AT graph like this, and this is your 0 0 origin always, and I am giving this coordinate as 2 2, and I want to find out this is the question. So question is velocity, average velocity of the following vehicle for which this graph is given will be option 1 10 meter per second. Remember, this is in meter per second square axis, and this axis is in second. Okay, so 10 meter per second, 100 meter per second, 1 meter per second. Option 4 none. Which option is correct? So very easy. You need to calculate the area, because they are asking for average velocity. So in this, whatever area is covered, like this area, that area you need to find out. But how will you figure out that area? Very easy. This distance, because of coordinate is 2 2, so height is also 2 and base is also 2. So you know the formula of area, that is nothing but 1 by 2 into base into height. So 2 will get cancelled, so we got 2 meter per second. So 2 meter per second is not there in our answer, so we will tick none. Some students may think that 1 and 2 they are closer, but guys, actually this data is not that different, so you should choose none. You should not think that okay, 1 is closer to 2, so choose 2. No. Okay, now see, graphs over. Now when I'll be teaching you different questions from different competitive exams, then what will happen? There will be a physical situation given. With the help of physical situation, we have to draw the graphs. Sometimes graphs are there. With the help of those graphs, you have to find out different graphs. And sometimes graphs are given. You have to find out that which of the following option is representing the right situation for this particular graph. I mean, few questions will be dealing. Okay, but see, question part I want to take in the last, after completing all the topics, because many students are following this lecture series for their board exam preparation. Okay, they are not following this right now for IIT mains. For IIT mains, you can watch these lecture series later also. Right now, if you are focusing on your board exam, or it depends, because now see, it is public on YouTube, so you can practice in your way. Or if you want to know that how should you practice, when to study, what to do, blah blah things, so for that you join me on WhatsApp. So my WhatsApp number is there, or directly one link is there in the WhatsApp, that is my group link, so you can join using that link. Okay, and I hope you are enjoying this, and if you have any doubt we can work out on WhatsApp. You just text me on WhatsApp. Okay, so this was your 80 graph ideas. Now from next class we are going, from next videos we are going to start our equation of motion, and after this topic we will solve previous year all standard and good problems. Okay, let's meet in next video. That will be our lecture 18.